Another example, let's look and identify or see if we can identify its zeros. So that being the case, I want to set this function equal to 0 and solve for x's. First thing I might do is multiply through by a -1 because I like having my leading coefficient being positive. It looks like there is something in each term I could factor out. I could factor out an x squared. And I think that trinomial is factorable. And in fact, it's factored to x minus 2 squared. For this to be true, either x squared has to equal 0 or x minus 2 squared has to equal 0. And that happens at x equals 0 and x equals 2. So in this particular function, I have two zeros, or two roots, or solutions. And if I wanted to graph those a little bit, there's something we can discover. We know that 0 and 2, so let me just mark off those 2 points. What are some things that we can determine on this graph? We know that we have a solution at 0. We have a solution at 2. It's in behavior of this graph. Its leading coefficient is negative, so I know that my graph starts out here and starts to work its way up to 0, and its in behavior as x's grow large is decreasing as well. And so I have those components of the graph I know. It touches or crosses at 0 and 2, and its in behavior is decreasing on both sides. What we're going to do here is we're going to try to figure out how to connect the rest of those dots. Now in our previous video, I was just able to start to draw the graph, but I said I don't know how to connect the points. And the reason why is I want to introduce to you another idea about roots. And it's called the multiplicity of roots. And the multiplicity of roots will help us understand some more key features of what's going on. So remember this example we did? We got an x equals 0 and an x equals negative, or x equals a positive 2. Well, that's not exactly what we got. We really got in this one that I have two x's. So x equals 0, and I have another x equals 0. Over here, this x minus 2 squared, well, that's really an x minus 2 and another x minus 2. So you can see then that I have my solution 2 showing up 2 times. So I have an x equals a 2 and an x equals a 2. And what we call that is that when I have roots that show up multiple times, we call that the multiplicity of our zeros. And a key feature is that if our multiplicity is even, so in this particular case, I have an even number of zeros being solutions to this particular one, that tells me then that the graph at 0 doesn't change sides. It just merely touches the graph like that. The sign of that function doesn't change at this particular point. Rather, at this particular 0, my function remains negative, but it just touches at 0. Likewise, the other point at x equals 2, its multiplicity is also even. I have two solutions of 2, or 2 is a multiplicity of itself, and it shows up 2 times, which is an even amount. And that likewise tells me at this point 2 on this graph, my graph just merely touches at that point. It doesn't cross over from negative to positive. The value at this point doesn't become negative, then all of a sudden becomes positive. Rather, at the value of 2, and just a little bit before 2 and a little bit above 2, my values are negative. So then I can look at the rest of my graph, and I know my graph is going to have some type of a look like that, where we've already identified its in behavior, we identified its roots, and now we notice that the roots were a multiplicity 2, multiplicity of an even number Therefore, the graph just touches the point but doesn't cross. If I had a multiplicity of an odd number, what do you think would happen? Yeah, it would cross. All right, there's more that we're going to talk about exactly how they cross coming on up later, but that's what I want you to understand and know for now is this idea of multiplicities of zeros.